Hi dear students, welcome to Geeta's classes. Today we are going to revise the entire topics of ordinary differential equations of first order. Actually this is also unit 1 of ordinary differential equations and vector calculus for first year R22 Jntuh. It is not only for Jntuh, anyone who wants to study about the first order differential equation, this class will be useful. So let's start the topics. So this is the definition. If you read that definition, you may not be able to understand easily. I'll give you one example. I'll explain. After that, let us see the definition. So if you have the equation y is equal to sin x, this is an ordinary equation, right? So this is equation number 1. If you differentiate 1 with respect to x, what will you get? Dy by dx is equal to cos x, right? So what about 2? It is a differential equation. First one is one equation. Second one is differential equation because it contains the differential coefficient dy by dx. So any equation which contains the differential coefficients is said to be differential equation. So 2 is a differential equation which is formed from the equation 1. So what did we do? Just differentiate it. We have not done any other operation. Okay. So from this, if you want to solve this differential equation, what do you mean by solution of differential equation? If the differential equation is given, if you want to solve the differential equation, integrating 2, what will you get? Dy by dx. If you integrate, integral of dy by dx with respect to x is y, right? And a different integral of, or I'll write one more step, integral of dy by dx into with respect to x, that is in right hand side it is cos x dx, right? So here in the left hand side we will be getting y, and right hand side we have integral of cos x is sin x. What is this? This is our equation 1. So equation 1 is the solution of the differential equation 2. So solution means for the differential equation, y is the constant, that is a dependent variable, x is the independent variable, right? So find the dependent variable y as a function of x which satisfies the differential equation. That is called the solution. So here 1 is the solution of equation number 2, that is the differential equation. So always solving the differential equation means find the dependent variable in terms of independent variable as a function of independent variable which satisfies the differential equation. That is said to be the solution. Okay. So if the solution is formed, if the differential equation is formed from the solution just by differentiating, so this is an exact differential equation. Okay. 2 is exact differential equation because it is formed just by differentiating without any further operation, right? So now you read, if mdx plus ndy is equal to 0 is a first order differential equation where m and n are real valued functions of x and y, then it is said to be an exact differential equation if there exists a function f of x comma y such that d of f of x comma y is equal to mdx plus ndy. That is, if you can write, if it is formed just by differentiating, you will be able to write it as d of some function is equal to mdx plus ndy. That is, exact differential equation can always be derived from its general solution directly by differentiating without any subsequent operation. Okay. So how will you find out? It will not be just like this example. It may not be that easy, right? So sometimes if the differential equation is given by this mdx plus ndy is equal to 0, it is said to be exact. You can find out whether it is exact or not, but just by checking this condition. Dou m by dou y is equal to dou n by dou x, where m is given here. If the given equation is of the form mdx plus ndy is equal to 0, differentiate m partially with respect to y, differentiate n partially with respect to x. If both are equal, then we say that it is a exact differential equation. Okay. What do you mean by first order? if you have y is equal to f of x, dy, if you differentiate once, dy by dx is equal to f dash of x. This is first order differential coefficient. Again, if you differentiate, you will be getting d squared y by dx squared is equal to f double dash of x. This is second order differential equation. Okay. So it depends on how many times you are differentiating with respect to x. Okay. So now in this unit, we are going to deal only with the first order differential equations. Now solution of exact differential. So how will you find out m dx plus n dy is equal to 0 is exact or not? So first condition is you have to check dou m by dou y is equal to dou n by dou x. If they are equal, then we can say that it is exact. If it is exact, then the solution is given by integral of, remember, integral of m dx plus n dy is equal to constant is the solution. Okay, but we have some condition. So here when you are taking m dx, you have to keep y as constant, and here you are considering n dy, you have to consider the terms of n not containing x. You have to consider the terms of capital N only. If they don't contain x, then only consider. Otherwise, don't consider the terms. Okay. Equal to C is the solution of exact differential equation. So it is very simple. You have to find out this integration. Okay. Now, if it is not exact, if it is not satisfying that condition, then it can be made exact just by multiplying a function u of x comma y, which is called the integrating factor. You have to just multiply, you find one function of x comma y which is called integrating factor. You can multiply the given equation by integrating factor, then you will be getting you can make the given differential equation as exact just by multiplying this function. Okay. So what are the methods to find out integrating factor? First one is grouping. How will you get this? If you get d of x comma y, differentiating this with respect to x, what will you get? You can write, you can keep one function as it is and differentiate the other one, x dy, plus y into, keep the second function as it is. It is UV form. So x into dy plus y into dx. Okay. Similarly, d of y comma y by x means what? You have to differentiate the u by v form. So v squared in the denominator, that is x squared. Then start with x and differentiate this y. So dy minus, keep y as it is and differentiate x with respect to x. So dx. That is why x dy minus y dx by x squared. That is d of y by x. Okay. So you can write. So if you see this function, you can write it as d of y by x directly. And integrating this, we will be getting y by x. Okay. That is the integral. Directly you can integrate. Similarly, x by y. And we have some standard functions like this. X dy minus y dx by xy can be written as d of log of y by. If you differentiate, we can check this. Similarly, d of tan inverse of y by x is this function. So if you see the left hand side functions, directly you can group it and integrate. You will be getting the answer directly. Otherwise, sometimes if it is homogeneous, if you are not able to group them, then find out whether it is homogeneous or not. What is homogeneous function? Examples, xy plus x squared plus 4y squared, like that. All the powers should be the same. Okay, so here you have 1 plus 1 x and y. So 1 plus 1 x 1 plus 1 2. Here x squared power 2. Similarly 4y squared power 2. All the powers should be the same. Then it is homogeneous. If it is homogeneous, you can find out the integrating factor as 1 by mx plus ny. We know what is m and n. Directly multiply m by x and n by y and add them and put it in the denominator. So 1 by mx plus ny, provided the condition is the denominator should not be 0, right? So mx plus ny not equal to 0. Next method for finding the integrating factor is, if the given equation is of the form f of xy into y dx plus f of xy into x dy is equal to 0. What do you mean by f of xy? The examples are x squared, or you can directly write xy, or you can have x squared y squared. X squared y squared means what? Xy the whole squared, right? Similarly, if you have sine of xy, you can have cos of xy, log of xy, like that. Or sine of x squared y squared also you can have. Whatever may be the function, it should be of the form xy. Okay. Then it is said to be f in the form of fxy, f of xy, and you should have one f of xy into y dx, and second one should be x dy is equal to 0. If it is in this form, then multiply m by x and multiply n by y and subtract from that. So 1 by mx minus ny will be our integrating factor. That is third one. Then fourth one is, if it is not possible to find out like that, then you can go for the next checking. You have to check like this. So dou m by dou y minus dou m by dou x divided by capital N is equal to a function of x alone. Then the integrating factor will be e power, whatever function you are getting here, you just integrate with respect to x and write in the power of e. Similarly, dou n, if it is not possible, then go for the next one. Dou n by dou x minus dou m by dou y by m. So remember, if you are starting with dou m by dou y here, then divide by capital N. If you are writing dou n by dou x here, then divide it by capital M. Okay, if it is a function, whatever is in the second one, you write in the denominator. If it is a function of y alone, here you have dou n by dou x. So it is a function of x alone means n. Okay, and m by y. So m means here y. Remember, try to relate them like that. Then if it is a function of y alone, then integrate this one with respect to y. Then write in the power of e. That will give you the integrating factor. So in all the different 5 cases, find the integrating factor. What is the use of integrating factor? Just multiply the integrating factor with the integrating factor will be a function of x and y. Okay, and multiply this one with the given differential equation so that it will become the become exact differential equation. After writing exact differential equation, you can write the solution as integral m dx plus n dy is equal to constant as the solution. Here you have to keep x as constant, y as constant, and you have to consider the terms of n not containing x. Okay, containing x. That will be our solution. Next is linear differential equation. What do you mean by linear differential equation? We have two different types of linear differential equation. One is dy by dx. First form is dy by dx plus p of x into y is equal to q of x. This is actually linear in y. How will you say that linear in y? Here you have y and dy by dx. All the remaining will be a function of x. You have to find out like that. Okay. So y and only dy by dx. No other function of y. All the others are functions of x only. Then what will be the solution? Y into, you have to find out the integrating factor first here. So integrating factor will be e power of integral p of x dx. Whatever you have here, the coefficient of y, that is our p of x. Okay. So p of x dx. Then after finding the integrating factor, then the solution is given by y into integrating factor. If it is linear in y, you have to write y into. Integrating factor is equal to integral of right hand side whatever you have, that is q of x into integrating factor into dx plus c is our solution. Another one is it may be linear in x also. In that case, if it is linear in x, how will you find out it is linear in x? Dx, the equation is of the form dx by dy plus p of y into x is equal to q of y. Q of y. So you have x and dx by dy, and all the others will be functions of y. Then you should know that it is linear in x. If it is linear in x, then the integrating factor will be e power integral of p of y dy. What will be the solution then? The solution is given by x into integrating factor. Because it is linear in x, the solution will be in x. Here the solving this equation means find x as a function of y. Okay. X is dependent variable, y is independent variable here. Dx by dy we have. So find x as a function of y as the solution. So x into integrating factor is equal to integral of q of y into integrating factor into dy, because it is q of y integrate with respect to y. So plus c. This is our solution. Next is Bernoulli's equation. We will get one definite question from linear or Bernoulli's. Okay. So if the equation is of the form dy by dx plus p of x into y is equal to, if you have only q of x, it is linear. Then otherwise if you have y power n, then it is called Bernoulli's equation, which can be reduced to linear equation. How will you reduce it? Divide throughout by y power n. Dividing by y power n throughout this equation we get, and substitute. Okay, what will you get here? 1 by y power n into dy by dx plus 1 by y power n minus 1 into p of x is equal to q of x, right? So here whatever you have, 1 by y power n minus 1 is equal to z, or you can write z is equal to y power 1 minus n, right? Whatever you have the coefficient of p of x, this should be substituted as z. Then we can reduce it to a linear equation, can be reduced to linear equation which will be linear in z. Okay. Then solve as usual. Then again substitute back for z. Okay. That is Bernoulli's equation. So Bernoulli's equation means y power n you have in the right hand side. Q of x will, if you have only q of x, it is linear. If it is multiplied by y power n, then it is Bernoulli's equation. So divide throughout by y power n, and whatever you have here you substitute as is z. Then reduce it to linear equation, and which can be solved by linear equation as usual. Okay. Then we have Newton's law of cooling. The rate of, this is the statement, the rate of change of temperature of a body is proportional to the difference of the temperature of the body and that of the surrounding medium. What do you mean by that? That is d capital T by dt is proportional to the difference between the surrounding temperature and temperature of the body. Assume that the temperature of the body is capital T. Okay. Then dt by dt, the rate of change of the temperature with respect to time, is proportional to the difference between T and T naught. That can be written as dt by dt is equal to k into T minus T naught, where k is the constant of proportionality. But always the unless otherwise we give external temperature, it will be decreasing. If you start one temperature, if you consider one hot body, if you keep it outside, what will happen? Automatically the temperature will be reducing. That is why it should be written as minus k. Okay. Then we have to solve this differential equation by, this is a first order differential equation. So you can solve this by separating the variables. So when you separate the variables, what are the variables we have? Capital T and small t. So dt by T minus T naught is equal to minus k into dt. That is dt by T minus T naught is equal to minus k into dt. So integrating both the sides we get log of T minus T naught is equal to minus kt, plus for my convenience I am taking the constant of integration as log c, and this can be written as log of e power minus kt, so that I can combine this log c. So left hand side we have log of T minus T naught. that is t minus t naught is equal to e power minus kt into c. Okay, this can be written as log of c into e power minus kt. So t minus t naught. So t is equal to t naught plus c into e power minus kt. This is our equation. Solution of the Newton's law of cooling equation. Okay. What is the differential equation? Dy by dt is equal to minus k into t minus t naught. This is our equation number 1. So solving this, we get this is equation number 2. So in this Newton's law of cooling, one definite question you can expect either from Newton's law of cooling or natural growth and decay. Okay. So here small t will be given, you have to find out capital T, or sometimes capital T will be given, you have to find out small t. That is, after some time what will be the temperature, or how much time will it take to reach this temperature. Okay. Or these are the two. Capital T will be given and small t will be asked, or small t will be given, you have to find out capital T. Okay. Using the given conditions, you have to find out the constant C and K, then substitute whatever is asked. Then next is law of natural growth and decay. You will have that substance, and dx by the rate of change will be either decreasing or increasing. So dx by dt will be proportional to the body. Okay, so dx by dt will be proportional to x. So sometimes if it is growth, then dx by dt can be written as constant of proportionality as plus k, k greater than 0. Or if it is decay, this is for growth. And if it is for decay, then dx by dt will be minus kx, where k is greater than 0. K is a constant which is greater than 0. Okay, this is a positive. If it is negative, again this will become positive. That's why k greater than 0. If you consider only k, it is a positive value. Okay. So if it is growth, kx, decay, then minus kx. Then as we have done in Newton's law of cooling, solve this equation also. And accordingly, whatever is asked in the question, we have to find out that value. Okay. After some time, what will be the value of x? Or small t will be given, you will be asked to find out x, or x will be given after some time. What will be the value of x, or this will be reduced to, or growth will be this much time, after what will be the time, how much time will it take. So these are the two types of questions you can get. Next is orthogonal trajectories. Orthogonal trajectories means what? You will have one family of curve, given one family of curve. Family of curve means it may be, consider the family of circles. Okay. Suppose if you have the equation x squared plus y squared is equal to a squared. So according to the value of a, if it is 1, you will get one circle. If it is 2, you will get one circle. If it is 3, you will get another circle, and so on. Right? If you can find out one equation of one line which intersects all the members of this family orthogonally. Orthogonally means what? At right angle. Okay, if it meets at right angle, then this curve is called orthogonal. This line is called orthogonal trajectory. One curve also. Sometimes, or if you can find out a family of family of straight lines or curves, which is for every family, every member of each family will be orthogonal to each other. If you have two families of curves, then every line is intersecting the circle in at right angles. Then both the families are said to be orthogonal trajectories of each other. Okay. So what is the procedure? F of x comma y comma c will be given. This is the given family. You have to differentiate and eliminate the constant c and form the differential equation of first order. This is our differential equation of the given family. And replace dy by dx to as minus dx by dy. Replace dy by dx by minus dx by dy. Why like that? It is actually minus 1 by dy by dx. That only we have written as minus dx by dy. Okay. Why like that? So that the product of their slopes at each point of intersection is minus 1. Okay. So if you have M1, M2, you would have studied two lines are said to be orthogonal if their slopes, product of their slopes is -1. Using that concept only we are finding here. So so that the product of their slopes at each point of intersection is -1. And then what will you get? F of dy by dx is replaced by minus dx by dy. So what is this? This is the differential equation of the orthogonal trajectory. If you solve this equation, then you will be getting the family of orthogonal trajectory. So f of x comma y comma c will be given, that is given family. Okay, then form the differential equation f of x comma y comma dy by dx is equal to 0. This is differential equation of given family. Okay, then replace this by dy by dx by minus dx by dy. Okay, that is capital F of x comma y comma minus dx by dy is equal to 0. This is the differential equation of orthogonal trajectory. So solving this, we will be getting capital X comma y comma another constant k is equal to 0. That will be the orthogonal trajectory equation. Okay, so very simple. Just differentiate and eliminate the constant. Replace dy by dx as minus dx by dy. Then solve. You will be getting the equation of the orthogonal trajectory. So these are the formulas you have to remember in the unit. I hope you would have understood all these things. Please practice some problems using this. Okay, so these are the formulas you have to remember. These are the concepts you have to remember. And please practice some more problems using these concepts. Hope this will be useful for you. Please share it with your friends so that it will be useful for others also. Thank you so much for listening.